let's look at the law of sines. Okay. So let's say we have a triangle, and let's suppose that we call this A, we call this B, and we call that angle C. And then what we do is across from A, we have little a. And across from B, we have little b. And across from C, we have little c. We usually use lowercase for sides and uppercase for angles. Now, the following holds true. So it turns out that if you have a triangle like this here, ABC, ABC, then if you go sine of angle A divided by A, if you go sine of angle B divided by little b, and if you go sine of big C over little c, then it turns out that all three of these fractions are equal. And what we'll usually do when we solve problems, usually we'll have like one fraction equals one other one. We usually won't have three of them. We'll have one of them equals another. So now that we established what is called the law of sines, let's do a few problems. Yeah, let's wipe this off. So an example, let's say solve for, let's just keep A, B, and C. Let's solve for little b. And here's what you're given. You're given a triangle like this. Let's say that this is like 5. Let's say that this is little b. And let's say that this is 33 degrees. And let's say this is like 40 degrees. Just making this up here. So based on the law of sines, we could go like this. We could go sine of 33 over 5 equals sine of 40 divided by b. Right, that's the equation that we can create. And then what we can do is we can go cross multiply. We can go cross multiply. So we would have like, this would be like b times sine 33 equals 5 times the sine of 40. Now we're trying to solve for b. So we'll divide both sides by the sine of 33. And we're pretty much done, right? Because like these cancel, those are gone. And then b would equal whatever this is here on a calculator. So while you guys copy that down, I'll type this in for us like that, and then sine 33. So about 5.9. So b is about 5.9. Final answer. B is about 5.9. So why don't we try one more problem? And let's say that for this one, let's say that little a is like 8. Let's say that little c is like 10. And let's say that big C is like, I don't know, something like, let's say 63 degrees, just making this up. So the goal is to solve for big A. How about a picture? And let's say that this is A, B, and C. You could draw it however you want. It doesn't really matter in terms of the A's, B's, and C's. The numbers will adjust themselves. So with this picture, little a is 8 and little c is 10 and angle C is 63. The goal is to find A, this angle, right? The angle that's right here. That's the goal, that little guy. So why don't we set up law of sines? So we have sine of 63 is to 10 as the sine of angle A is to 8. And kind of like we did before, we can cross multiply. We can go like that, and we can go like that. We can cross multiply so that we get 8 times sine 63 equals 10 times the sine of A. And now to get A alone, we can begin by getting rid of 10. Divide both sides by 10. So this is gone. So we're left with sine of A equals 8 sine 63 over 10. So we're like 99% done. So now looking at what you have there, you got to ask yourself, how do I get A alone? Right? How do I finish this problem? How do I get A alone? How do I make sine go? I want that to cancel. Right? I want sine to cancel, so it's just A by itself. So in order to do that, remember that to knock out sine, what you could do is use sine inverse of both sides. Because on the left, sine inverse cancels with sine. So you're left just with A, which is the goal. But then you got to type all that into a calculator. And I believe I typed it in here just a moment ago. And I got it's about 45 degrees. So on a calculator, I get that A is close, something close to 45 degrees or so. And that was the goal, to find capital A. So this was a brief video, I know, but it quickly recaps the law of sines.